Hey guys, I'm going to work through a action potential as quickly as possible. First thing we need to remember is that when the cell is at rest, inside the cell, it has more concentration of potassium, and outside the cell, there's a higher concentration of sodium, calcium, and chloride. That's going to be important because this higher concentration, let's go to a lower concentration, it creates a potential for them to move. The other thing is inside the cell, it is negative. It is negative 70 millivolts. So that is considered our resting potential. So when our neuron is at rest, it is at negative 70 millivolts. And then a stimulus occurs. A neurotransmitter sent from a previous neuron binds to the receptor on the dendrite. The neurotransmitter would be the ligand binding to the receptor. This is a ligand-gated sodium channel. So when the neurotransmitter ligand binds, it opens the channel so that sodium, which is all outside the cell, enters and it comes in, and as it comes close, as it comes in, it pushes all the other positive charges forward because positive charges repel one another. So it repels it forward, and as this cell gets more positive, if this axon hillock, which is covered with a high density of voltage-gated sodium channels, different than ligand-gated. These are voltage-gated because they open at a charge, and this charge is negative 55 millivolts. So if the charge gets positive enough from negative 70 to go up to negative 55, it opens these voltage-gated sodium channels, and sodium is going to come in to the cell through all of these channels. And as it comes in, it repels the charges down. So the positive charges go down. And as it gets to negative 55 here, this voltage-gated sodium channel opens and sodium comes in. And it continues to repel down the axon of the neuron. Now, as this positive wave is happening, right behind it, as it gets more and more positive, when all this sodium comes in, it's going to shoot all the way up to positive 40. At positive 40 millivolts, these gates close, and another gate opens, the potassium channel. The potassium channel opens, and the potassium, which started out high inside the cell, is going to go out of the cell. So as the potassium leaves, this is now going to get negative again. It's going to repolarize and become negative. So as the positive wave goes, the negative, it repolarizes it behind, becomes negative, becomes hyperpolarized. It actually goes down lower than negative 70 all the way to negative 90. At negative 90 degrees or millivolts, it is hyperpolarized, and a pump activates called the sodium-potassium pump. And what the sodium-potassium pump does is it resets the sodium back out of the cell and the potassium back in. So the pump is going to pump 3 sodiums out for every 2 potassiums in. 3 sodiums out, 2 potassiums in. So let's continue on with our wave. So This wave of positive happens when it gets the positive sodium, when it gets to negative 55 here. This sodium channel opens and a bunch more sodium enters and it repels down the axon further. It repels down, it pushes it down. Right behind it, it is switching back because the potassium gates open, potassium leaves, becomes repolarized, and then the sodium potassium gate resets it. So as the positive charge goes along, there's a wave of negative behind it. So the positive charge is still moving along, and the positive sodiums get here, it gets to negative 55, and this sodium channel opens here, and you get this positive wave gets pushed down, 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 down. And here all the way in the axon terminal, when it gets to positive 40 in the axon terminal, the calcium channel opens at positive 40, and the calcium enters the cell, and that's where it's going to bind to a vesicle and help the neurotransmitter leave and be released to the next neuron to stimulate the next action potential, and it continues to move on. I hope that helps.